Hello friends, I am Vidya Kodgirwar from Modern College of Engineering, Pune. Welcome to the video tutorial on Firebird V Robotics Research Platform. This tutorial is based on Atmega 2560 microcontroller which belongs to AVR family. In this, we will learn about motion control on Firebird V robot. That is, we are going to study different motions possible on this robot. As there are two DC motors on this robot, we will learn various motions required in robotics using Atmega 2560 and LT293D IC. Let us see the agenda for this discussion. Ports in the Atmega 2560. Then we will see the basic movements required in the robotics, understanding L293D IC, then for motor interfacing, pin connection, logic table, and a small example of the C code. Atmega 2560 is a 100 pin microcontroller. Out of these 100 pins, 86 pins can be used as an input or as an output pins. When these pins are grouped together, it is called as a port. This device has 10 8-bit ports, that is port A to F and port H, J, K, L. In addition to this device has one 6-bit port which is port G, and all port pins can be configured as an input pin or as an output pin. To add these ports, this device has provided three different registers: DDRX, port X and pin X. X stands for any port, that is A to H and JKL. Now think that how to configure these ports as an input port or as an output port. Let's see. For example, I want to make port D as an output port and I want to transmit the bit pattern D5 on this port. Then first step will be make the port D as an output port by writing FF in DDRD register. And second step will be put the data on port D. That is, we have to write bit pattern D5 on port D. We can consider one more example. Suppose I want to make port A as an input port with pull-up activated on all port pins. Then first step will be make the port A as an input port by writing 00 in DDRA register. And to activate pull-up register, I have to send the bit pattern FF on port A. Then various motions are possible on the robot by rotating the wheels in direction. To rotate the robot in forward direction, I have to rotate the both wheels in the forward direction, that is in the clockwise direction. Then backward motion is also possible, and then in the left direction and right direction also we can rotate the robot. In addition to above, some more motions are also possible, that is soft right, soft left, backward left and backward right. For this actually we need to rotate the motor in anti-clockwise and clockwise direction. To rotate the motor in anti-clockwise direction, the battery connection should be like this. Positive terminal of the battery should be connected to positive terminal of the motor and negative terminal of battery should be connected to negative terminal of the motor. And to rotate the motor in clockwise direction, the battery terminal connection should be reverse. That is, negative terminal should be connected to positive and positive terminal of battery should be connected to negative of the motor. Think on that, how the direction of this motor is controlled. Who does all this? Let's see. With the help of 293D IC, we can control the different directions of motor. In this device is 16-pin IC. Pin number 1 and pin number 9 are connected to the port L pin 3 and 4. And pin number 2, 7, 10 and 15. These pins are input pins of this device, and these pins are connected to the port A pin 0, 1, 2, 3. And pin number 3, 6, 11, 14. These are the output pins of this device which are connected to the motor. And pin number 8 and 16, these two pins are supply pin. Pin number 8 is 12 volt supply to drive the motor, and pin number 16 is 5 volt supply which is required for the operation of this device. Then the connection of motor with the port pin is like this. The direction control pins are connected to port A, and to enable the motor driver IC is connected to port L. Port A0 and port A1, these two pins are connected to the left motor control, and port A2 and port A3, these two pins are connected to right motor control, and PL3 is used to enable the left channel, and PL4 is used to enable the right channel. Then by writing the appropriate bit into the port A, we can rotate the robot in different directions. To move the robot in forward direction, we have to write 0110, that is 06, to port A. And to move the robot in backward direction, we have to write 1001, that is 09, to port A pins. In same way, by writing the appropriate bit into the port A, we can move the robot in the different directions. Let's see the syntax for C program. This program is written by using the AVR Studio platform. Initially, we need to include some header files like io.h, interrupt.h and delay.h. In this program, the delay is in the millisecond. Then in the main program, we have to call the function motion pin config function. Here in this function actually we have to configure the different port pins. And then in the while loop, we have called some functions like forward, then stop, delay functions. Between two operations of the robot, we need to call the delay function, because Atmega 2560 cannot perform the two operations simultaneously. In between two operations, at least 1 millisecond delay is required. Then to configure the pins, we can write the function motion pin config function. In this function, the DDRA register is loaded with 0F value, so that port A will be configured as a output port, and 00 is returned to port A, so that initially motor will be stopped, and DDRL and port L we can use to enable the port pins. Then to move the motor in forward and reverse direction, we can define the different functions. Like for forward, port A equal to 06, and when we want to stop the robot, we have to write the function like port A equal to 00. In same way, we can write the different functions. Think on that. Are you able to define all related motion functions using logic table? Yes, you can. You can write the functions for backward, right, left, soft right and soft left. Thank you.